Hello, 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 everyone, and welcome to the Science Friday live stream. My name is Sandy, and I'm the Science Friday Education Program Manager, and I am so thankful that you're joining us today. We have a very special event planned. I am joining you from Northwest New Jersey, near the Delaware Water Gap. Speaking of which, tell us where you're from. We would love if you could use the chat to tell us where you're joining us from. A few people I can see have already started to list where they are from in the chat. We've got Manchester, North Hampshire, New Hampshire, also from New Jersey, Cape Cod. So if you are signed into a YouTube account, you can join us in the chat to the right or below this video and just let us know where you're watching from today, because we'd love to know. If you don't know us, I'd like to say that Science Friday is your one-stop shop for all things science news. We're very well known for our weekly science show, our radio show, which is broadcast every week on Fridays at 2 p.m., of course. And you can listen to us live each week on our website at sciencefriday.com or on your favorite radio station. Just click the listen banner on our website, and it's easy to listen anytime. And in fact, the live show will start right after this live stream today. So you can get 3 solid hours of awesome science today. What a way to spend a Friday. Of course, for so much more, we also have wonderful, wonderful science articles, educational activities, and community experiences like our book club, which you're enjoying today. But we are here to talk about this month's pick, Many Things Under a Rock by David Scheel. Many of our fellow readers, you may have come into this month's book club thinking, how do you study an animal that does not want to be found? Scheel explores the secret lives of octopuses who are clever and curious and masters of staying hidden. And this book blends science and storytelling to show us how much mystery still lies beneath the waves and what it takes to uncover it. Anyway, we're going to dig into all of that very, very soon. And if you want to keep the conversation going, you can do that in our online community space hosted on Mighty Networks, which you can join at the link that we'll provide in the chat. As a friendly reminder before we get started, Science Friday is committed to providing a welcoming and harassment-free environment for all members of all ethnicities, ages, gender and trans statuses, sexual orientations, physical abilities, national origin, beliefs, and any other dimension of diversity. We've created a code of conduct, excuse me, which you can read in its entirety on our community space to help us create a safe and positive community experience for everyone. And, and because we believe in providing clear expectations to provide a respectful community, please excuse me, I have a little bit of a cold. Summer colds are the worst. But here are the basics. Be supportive and respectful when speaking with one another and asking questions in the chat. Share generously and listen closely. You can add thoughts or ideas about our conversation in the chat, even if it isn't, strictly a question for our guest. Please interact with one another. We're going to do our best to stay on topic. We're here to discuss this month's book club pick with Many Things Under a Rock, so marine biology, cephalopods in general, ocean exploration, and all those kinds of related topics. And we reserve the right to ban anyone who engages in demeaning, discriminatory, or harassing behavior today. All right, thanks for sticking with me. And with that, it is time to welcome our special guest for today's live stream. Please join me by posting your emoji of choice in the chat to welcome him. David Scheel is a behavioral ecologist, author, and professor of marine biology at Alaska Pacific University, and has researched the behavior and ecology of octopuses for over 25 years. He starred with Heidi the octopus and his daughter Laurel in PBS's Octopus Making Contact. He lives in Anchorage, Alaska. David, thank you so much for being here. And as a reminder to our audience, we want your questions at any time during this event. If you have a question or comment for our guest, put it in that chat and we'll try to get to as many questions as we possibly can. David, welcome.
Hi, Sandy. Thank you for having me.
I'm really thrilled to have you here today, and I know our book club is really excited as well. So maybe we could start off with a reading from your book, because, and I want to just make clear, if you haven't read the entirety of Many Things Under a Rock, that's okay. I know some folks are still working through it. You can still ask questions. There's plenty of just general knowledge, but I thought we'd start with a really great reading from chapter 10 entitled Storied Octopuses. If you'd like to share with us, David.
Sure. In the story, I said, glancing up with trepidation, there is a hunter. Dr. Apila Colorado was listening. Apila is of Oneida Gaul ancestry, and she devotes her energy to promoting indigenous science, an ancient way of knowing used by tribal people for generations. Indigenous science seeks not only to understand, but also to respect people and the natural world. Pila was about 5'2", with a broad face and luxurious, thick black hair streaked with gray. How was it that I was telling an indigenous elder a traditional Aleut story? If she knew this tale at all, she knew more about it than I did. She and I were in Anchorage at the annual workshop of the Exxon Valdez Oil Spill Trustee Council on the traditional lands of the Dana Ina people. That year, the workshop emphasized the importance of traditional ecological knowledge to understanding natural systems. Apila was there to bring Native voices and indigenous science forward in the restoration process for Trustee Council support. She had just approached me to talk. Later, she would say that it was my obvious passion for my work and genuine concern for octopuses that drew her to me. I told Apila about the work I was doing with octopuses and what I thought it might offer for the work she does with traditional knowledge. In allegory, predators and prey are enemies, as was the case in the story I was about to tell Apila. Octopuses are hunters, but they are also soft, vulnerable prey, and the story I wanted to share with Apila intrigued me. Given a history of conflict between researchers and Native communities, it piqued her interest too. Maybe there was something for both of us to learn. So what is your next step? She asked. I had just finished the first years of fieldwork, and I expected to submit a final report to the Trustee Council. However, I was toying with a few ideas to continue working with octopuses. Tanya and I have found or been told octopus stories from coastal northwestern natives, the Aleut, Alutiiq, Eyak, the Tlingit, and Haida. I want to put them together with our experiences in the field and use the framework to write about octopuses. I showed her a drawing illustrating one of the legends and a photographic collage of octopuses. Apila seemed fascinated by a deep ocean image of a giant Pacific octopus. What is the story? She commanded, looking directly at me. In the story, I said, drawing a deep breath, there is a hunter. He hunts sea otters with the other men in his village. However, when he goes hunting, he never gets a single otter. The other men in his village are successful, but this man, he never gets any otters. One day after a hunt, he is paddling back to the village, again without any otters for his troubles, and thinking about what he should do to be successful. A great old octopus swims up alongside him. The octopus is as long as his bidarka. It grabs him and takes him below the sea to the octopus's house under a boulder. There, this huge octopus says to him, "Why do you never get any otters when you are out hunting?" "I don't know," replied the man. "Whenever I go out, I never get any otters." "Apparently, you have been eating in the evenings before you hunt," says the great octopus, and he reaches with one arm into the man's mouth and down into his stomach. He withdraws his arm, clutching grass and weeds. "Apparently, you've been walking in the evenings before you hunt," the octopus continues, and he rubs the bottoms of the hunter's feet, scraping off the skin, the calluses. He does the same to the hands. "Now when you hunt," the octopus says, "you will have great success. After each success, Be sure to lower to me the white heads of the sea otters. To this, the hunter readily agrees, and the octopus takes him back up through the sea again, so that the man may continue on his journey home. On the next hunt, the man cannot miss. Every time he throws his spear, he takes another otter. On the way home after the hunt, he lowers to the octopus the white heads of the otters he has killed. This continues for some time, until one day the hunter has a desire for a white sea otter head of his own. He keeps one and lowers the head of a black sea otter to the octopus instead before returning to his village. Some time after arriving there, he feels the ground shaking. Then he hears talk that the bay beyond the village is turning red. The hunter hears that an octopus's arms appeared above the water in the middle of the bay. At this, the man realizes that it is because of him that this is happening. The octopus throws the sea against the village, and all are swept away, it is said. Do you know what the story means? Apila asked as I finished relating the tale. I puzzle over this for a minute. The story was partly about the hunting taboos of the Aleuts and proper behavior. Another level in the story, on which the elder octopus in the story spoke to the octopus in me, is that octopuses give aid to the enemies of sea otters. I had seen otters in Prince William Sound and Cook Inlet floating on their backs, chewing on large red octopuses draped over their chests and bellies. I had found remains dropped from such meals during the intertidal surveys. Was the octopus speaking to me about its predators? The enemy of my enemy is my friend. These interpretations were not what Apila meant, however. Just like Western science, indigenous science has rules, Apila said as she tapped the drawing. And good things can happen to those who respect them. But if the rules are broken, her glance fell meaningfully to the last panel of the illustration, where the octopus had swept up to the sea into a tsunami that hung above the doomed village. I asked a question that had been on my mind. Do you think it is appropriate for someone like me to use these kinds of stories in my own work? She looked at me, understanding what I was asking. The stories belonged to the cultures that told them, no matter who wrote them down in the books where they appeared. The giant octopus is a central sacred archetype for indigenous people, she said. It symbolizes, it is a key to unlock the knowledge you are searching for. Be careful. You must ask permission, especially for the stories that have not been published.
Thank you so much for sharing that with us. There's so much truly amazing storytelling in this book. It's so much more than just a nonfiction science book, right? And so I think one of the discussions that's come up a lot is that you do share and center a lot of these indigenous stories about octopuses throughout the book. And I was wondering if you could tell us a little bit about why that was important for you to share and what that adds to a nonfiction book about marine biology.
Yeah, well, I mean, one of the reasons it was important to share these stories, I think, is that that's the way it happened. And you mentioned it's a nonfiction book. So to the extent that I was going to relate any part of my own story of getting into the business of studying octopuses and finding out new things about them, that was part of the story. That's part of the factual story. And so since it's nonfiction, part of the reason for including that was simply to be true to my own experience, to what happened, and to how some of these questions that I asked about octopuses came about. The original impetus for this study, it was an Exxon Valdez oil spill sort of damage study, and it was funded by monies from the settlement. And the reason that it received funding was because the Alaska Native communities had asked for information about, what had the oil spill done to the intertidal, and particularly to octopuses, because they were an important part of the subsistence harvest for Alaska Native people, and also, as you've seen, part of their culture.
Right. So I'm curious, how did you go about collecting these stories? Were there cultural considerations you had to keep in mind? Were there challenges you faced as you collected those kinds of artifacts?
Yeah, well, I'm a bookworm, so the first way I started collecting stories was just to open up books and read them and look where they were printed. This one that I just read, I found in a cultural study that included stories from. I'm just looking up here real quick what the source was. Aleut Tales and Narratives, collected 1909 to 1910. And, so these were anthropologists who had gone to the anthropologists we would call out in the field, but to the Alaska Native communities, come to town, or into the village, right? So, home. So, these people traveled from their own homelands. This particular author lived in Europe, in Denmark, I think, or something like that. And she was an anthropologist who studied communities around the world, and she traveled to the out to the Aleutians, and she met people there and talked to them and recorded what they said. And so I had this book, and it had that particular story in it. Some of the stories in the book were told to me by people when I was working in the communities. And, for a few years, I was privileged to work with some of the elders and have them take me out to the sites near their homes where they foraged for octopuses along the shoreline, and show me how they did it. And, just in talking to them. Those stories were not recorded with an anthropological eye. I didn't have a tape recorder with me, but I kept a journal every night, and so I would write them down later the same day after I'd heard them. So they're filtered through my own lens, obviously.
Right. But I think there's something very personal about taking the time to write down and journal those kinds of stories. Like it's different. It's a different interaction than recording it, maybe.
Yeah.
Yeah. We're getting a lot of questions about, since you brought up kind of this global way of looking at species and at octopuses and also at culture. We have the question, are octopuses sacred to certain cultures and global cultures, in the sense that they wouldn't hunt them but would protect them? Because I know you brought up that they are part of subsistence for many of the people that you work with. Do you know if there are maybe indigenous people that choose not to hunt the octopus?
Yeah. So as Apila Colorado said, she said, the octopuses are a central sacred archetype. And I think that's very true. But I don't think sacred in, sort of these cultures that you have in mind, the Tlingit, the Yupik, the Aleut, Moorea, Hawaii, etc. I don't think that sacred necessarily has the exact same meaning that we would have in, sort of mainstream United States culture. In the sense that, like I was brought up in a Roman Catholic church, and something was sacred, it kind of meant you didn't touch it, or you only touched it reverently. It certainly wasn't a part of your everyday existence. We would take the Eucharist, and it was done in an hour-long ceremony. And, it wasn't the main meal of the day. Right. And, the people that I've talked to about octopuses in their culture, eating them and catching them is a very important part of their way that they relate to the natural world. When you live, along a shoreline, I was at some places in Madagascar that, I was in a village in Madagascar where they harvest octopuses, and, they're on a road, not a paved road, but they're on a road that gets truck traffic, but not every day. And the nearest proper, what we would think of as a grocery store is maybe a 4-hour drive away, maybe 8-hour drive away. I mean, they're getting their food from what they bring down that road every 3 to 6 months, and the rest of it comes from the ocean. And so they eventually got connected to the global market for octopuses because it's a kind of a delicacy in Europe. And so we have people in, Andovaduaca, Madagascar, harvesting octopuses for the markets in Europe. But what they did eventually is set up sort of a rotating system of reserves where they close certain areas, but only temporarily, 6 or 9 months. And in that time, the octopuses can settle into those areas undisturbed and grow rapidly. And as long as they keep a portion of their area that each village fish is closed and rotate those areas, they seem to be able to harvest more octopuses than they would be able to if they had the whole area open to fishing all the time, because that recently opened area is always more productive, and the recently closed area is always building productivity.
And I know in the book you talk about some efforts to trying to essentially create farming, octopus farming, much as we have with fish, and that hasn't worked as well with octopuses.
Well, it's interesting. There's been a lot of pushback as the technical skills and the knowledge of the octopus life cycle have developed through studying octopuses. There are some labs in the world that are specifically working to close the life cycle in captivity, is what we talked about. It go from spawning adult all the way back down around to spawning adult repeatedly in captivity. And that's somewhat challenging for octopuses, but it's not impossible. And as that science and knowledge has gotten better and better, there has simultaneously been a development of sort of pushback against aquaculturing octopuses, and just the general perception that, maybe particularly our United States animal husbandry practices aren't all that great to begin with, our concentrated animal feedlot farming and so on and so forth. And do we want to bring a whole new type of animal that's very, sort of engaging and flexible and interesting and all of that into that kind of system? Or would it make more sense to somehow improve our own processes with all the animals we husband, instead of taking a system that has some serious drawbacks and receives a lot of criticism and applying it to a new animal?
And speaking of food, and we're getting some questions there. Stacy is curious if studying octopuses has impacted how you feel about them being used as food. In fact, she had a follow-up question asking if you eat octopus.
Yeah, I don't eat octopuses anymore. I have in the early years of this study, but essentially I find them much more fascinating alive than they ever could be on the plate. But at the same time, you kind of have to recognize that people have to eat. And so whatever we eat is going to create, we're going to be part of that ecology that we create and live in here on planet Earth. And so, I don't judge what other people eat. And that includes octopuses, just not the ones I'm working with at the moment, please.
So octopuses, and I want to kind of jump into some of the science, but octopuses have a number of tools that you describe in the book, and that makes it hard for predators to find them, including humans. And then they use these tools also as hunters. And so I'd kind of like to jump into some of those tools as they were. Alexa is very curious about octopus vision. And she asks, I had a really hard time conceptualizing octopus vision, specifically how they perceive polarized light, and wondering if you could explain that concept again.
Yeah, octopus vision is a tough one. I'll tell you, the science of vision and light is to me wildly complex. I attended a workshop for aquarium keepers, and I specifically went to they had a little sort of lecture series, and I specifically signed up for the lecture series having to do with light, because I was worried that I wasn't teaching it well enough to my students because it's such a complicated study. And judging by what I learned at those lectures, I'm doing okay. But in terms of octopus vision and polarized light specifically, our own human experience with polarized light is largely having to do with like polarized sunglasses, right? And it cuts the glare down. And what that glare is off of a flat surface of water or a piece of glass, that shiny bit that suddenly looks so much brighter, is all of the wavelengths of light. They oscillate like waves, and each wave oscillates along a particular plane. But in sunshine, the plane, it's a mixture. Some waves oscillate this way, some this way, some this way, so that the light itself overall is oscillating all the way around the circumference, right? All the way around the compass dial as it's traveling in a straight line. And polarized light is when a flat surface reflects only the light that's oscillating parallel to the surface, I think. And that way, because the ones that are oscillating this way don't bounce off quite as well. I think that's correct. And so a flat reflective surface can change the light from oscillating at random around the circle to oscillating almost entirely in a single plane. Okay, so underwater, the light that has come through the surface of the water is scattered by particles in the water, and it is generally unpolarized. But what are reflective surfaces that you can find underwater? Well, things like fish scales or crab carapaces.
Right.
And so those polarize the light locally underwater. And as it travels through the water, it gradually bounces off of other things and gradually gets depolarized. But what it means is if you can see polarized light underwater, you can see through the gloom a little bit further, through the murk a little bit further. And so that's one of the ways I've understood this, is that it helps an underwater animal pick up an approaching threat a little further away, for example, or recognize an approaching meal or a meal that's nearby somewhere a little bit more easily against the backdrop, because most of the light is not polarized, but things that are polarized kind of jump out at an octopus. And not only can they detect that it's polarized, they are detecting the angle of polarization, which gives them additional information. So much as we can detect the wavelength of light as color, they can detect the angle of polarization. I wouldn't say as color, but it's sort of analogous. It has a spectrum, right, of rotation. And so the octopuses are capable of detecting that and using it, making decisions based on it.
So, I mean, continuing kind of this thread of like some amazing, differences in octopuses. I mean, they're very adaptive, intelligent animals, and they have a very different nervous system and cardiovascular system and even basic biology than humans and mammals. And I'm wondering if you can describe some of those notable differences and why they make octopuses special. And beyond that, what we can learn from their biology that may inform our understanding of the world.
Yeah. Well, as a biologist, a zoologist, part of my field is to examine how animals, what animals have in common. Like, what are the deep evolutionary roots, right, that we can see unfolding in the various species and animals that we encounter. But of course, as a you know, as a person, we're also most familiar with our own biology. And so it's really, I think it helps a lot to start with what we know the best, which is us, and work our way out from there. And it, you know, you might say, well, isn't that anthropocentric? Well, yeah, but what else are you going to do, right? You can't start with things you don't know. And so we have to start somewhere. So, but the octopuses are really interesting because they've taken a kind of unusual twist on the whole thing. So humans are bilaterally symmetrical, right? Our left and our right sides are mirror reflections of each other, more or less. Our backs and our fronts are not. So we have a preferred direction of motion. We have a left and a right side, and then we got whatever happens behind us, right? And a lot of animals are bilateral, right? Bilaterally symmetrical. So an animal that isn't would be a jellyfish, right? It's round. It's got radial symmetry. An animal without symmetry would be a sponge. It's kind of could have almost any shape. Some of them, like a vase sponge, develop symmetry, but a lot of sponges are just kind of globular. Okay, so then we've got all the rest of the animals that have this bilateral symmetry: worms, insects, fish, clams, right? Even clams, kind of left and right side, pretty much the same. And the octopus too, two eyes in front, sort of the mantle, which is the body out behind, right? And then if you go right between the eyes, come down the front, you end up between the front pair of arms, left arm one and right arm one. And so it's 1, 2, 3, and 4 around the back, right? So 4 pairs of arms, but left and right. So it's bilaterally symmetrical, except the arms form that crown around the mouth. So it's radially symmetrical also. It has what we call a secondary radial symmetry. And that's kind of interesting because it changes the way the octopus moves. Octopuses don't preferentially move straight ahead. They actually typically move off at an angle where that's close to 45 degrees off of straight ahead. And the reason for that is everything in that direction, that lies in the most the view of that falls in the most sensitive area of their retina. And so they are and then they can use the array of arms basically to push them in that direction. Whereas if they move straight ahead, they're not heading towards something that they can see as clearly as they can slightly off to the side. They have they're like many of the other mollusks in that they have a semi-open circulatory system. I'm an animal behaviorist. I'm not an internal anatomist, but they have 3 hearts that pump their blood around their body. They have a main circulatory heart, and then each gill array has a smaller secondary heart. So there's 3 hearts. Their blood is not iron-based. The oxygen carrier in their blood is copper, and so their blood is kind of blue. It's cyan-colored. If we ask a human, you know, where are all the neurons in your body? They're in our head. Not all of them, but most of them. We have a very extensive nervous system, but something like 98% of the neurons in our body are in the brain. For the octopus, that corresponding number is closer to 33%, a third. And the rest of their neurons are distributed out around their body. And so they do a lot of sort of fundamental processing of basic motor motions and things like that without any involvement of the brain.
Wow. So, I mean, so it's kind of amazing to, as you mentioned, because we tend to like think of ourselves and then kind of move out to like understand everything else. When we do that, especially when we're considering something like octopus, what might we miss in the kind of comparisons that we might make? It's easy to say, well, I have 2 arms and they have 8 and we're right and left. But what kinds of differences between mammals and octopuses are maybe not as easy to notice, and what could we learn from those?
Yeah. Well, I think there's been this great villainization of sort of thinking about other animals from our own perspective, right? We call it anthropomorphization, right? To assume that some other entity's experience is like your own.
Mm.
And you can definitely go too far in that direction. But also cognitively, humans can't learn anything unless they can relate it to something they already know. That's how we learn. We scaffold knowledge. So you start without much knowledge. You begin to learn about how, a neuron firing here makes you hit yourself in your face with your hand when you're a little baby, right? And eventually you gain control of all of that, and your knowledge scaffolds on up. You learn to talk, you learn words, you learn the meaning of words, et cetera, et cetera. So to some extent, I think the problem, what we lose, is if we forget that there are differences and the differences matter. Right? But what we gain is we can get started. We can get started learning about those differences. And so you have to go down the middle path, I think. And I hope the book sort of illustrated that, right? That I started the book talking about my own experiences, but very quickly talking about octopuses and trying to find home, right? That was very deliberate because we all understand the value of getting home, right? And what that can mean, and what it means on a cold winter's day to have a fireplace to sit by, or what it means after a hard day at work when your colleagues have just been after you to do better, to come home and sit down and know that, okay, here I'm good enough, And so from there, how can we begin to explore the similarities and the differences? There are certain universals in animal life. You have to find shelter. You have to find food. You have to escape predation. You have to deal with others. Ooh. If you're lucky, you have to, and you're going to, if the species is going to continue, you have to find a mate. And these things are pretty universal. But what's fascinating is that there's lots of different ways to do any of them.
Speaking of those relationships, as I was reading the book, I've always kind of thought of octopuses as solitary creatures, but that really is not the whole story at all. And I was wondering if you could describe some of what those relationships look like between octopuses when they do come in contact with one another, because I found that really surprising.
Yeah, that is pretty amazing, and it was a really exciting thing to be involved with. So octopuses generally are solitary, and so most of the time when you encounter an octopus, you encounter one octopus. And if you're a scuba diver or whatever, any of our readers who've been underwater in the wild like that, or are frequent snorkelers, or just live along the beach, they know that's how you find octopuses, usually alone. But the presumption, I think, has sometimes been that they're so solitary as to be asocial. They are without social skills. They cannot manage a conspecific encounter. And, even saying that out loud that way, many of you are thinking, well, that's kind of silly to think that. You're right. But nevertheless, there was this presumption in some ways by, many octopus scientists, not all of them, but many, that octopuses just didn't care for each other. They actively avoided each other, and that was it. Except during mating, and then after mating, the female ate the male for a good meal. So some colleagues and I found this site that was nicknamed Octopus, and it was in an area with lots of food for octopuses, lots of predators, and very little shelter. And some sort of metal hunk, like a casing or a motor or something, had been cast overboard and landed in the silt and created a hard substrate. And we surmise that an octopus denned up under this for shelter. And then what they were eating in this area were these very abundant scallop shells. So, round shells, something like that, flat shells. And so what octopuses do when they forage is they leave the den, they go out and forage, and then because it's so dangerous, they come back to the den and they eat back at the den. And they eat the meat and they don't have any use for the shells, so they get discarded. So if you do that 100, 200, 1,000 times over a couple of years, pretty soon you have a really big pile of scallop shell discard.
Yeah.
And another octopus comes along and works it down into the sediment a little bit, and pretty soon you got a den next to the other den in the discarded shell remains. And that creates a new center to discard more scallop shells. So what we think happened is that over a period of a few years, this expanded into this area, and pretty soon there were like 16 octopuses finding dens in this little patch no bigger than an average living room. And, there was lots of food, there was shelter, and there were predators, so you wanted to stay in the shelter. But then you had to deal with this brand new annoyance. You had neighbors. Oh. And I'm sure the octopuses felt like that sucked, right?
Yeah, right.
But nevertheless, and this was what was fascinating, they had skills to cope with it. So they display at one another. That hadn't been written about in the scientific literature very much at all, only tangentially. They fight. They evict one another from their dens. They reach out and kind of bop one another. They throw debris at one another. And none of this had been described in studies of octopus behavior. And so as a behaviorist, to me, that was just exceedingly, just very fascinating.
Yeah, no, that's really, it's kind of funny to think. I mean, I think we all have interesting relationships with our neighbors. I don't know how I'd feel if I was an octopus. This came in from Ophelia, and she asked, would you talk more about how octopuses manage to learn so much without the benefit of parental modeling? Obviously, this is another comparison to humans or mammals.
Right. Yeah, of course, we tend to think of learning as humans, we tend to think of learning as modeled or, guided by books, and you're given exercises and studies, you go to school. But a lot of our learning as humans happens elsewhere. You learn when you go to the beach and you poke at things. You learn, sea urchins are sharp and the waves are strong, way stronger than I am. Seaweed is slippery. And you turn over a rock and you say, look at all this stuff living underneath the rock, right? And so octopuses have that curiosity that we have. And they learn, I think, in large part by being curious. They are always exploring and poking things and seeing what happens. And they do it very cautiously. But once they've established that something isn't going to attack them immediately, they're willing to risk a little more investigation. And, there's this charming story by the guy who first found that site that I was talking about, Octopus, that Peter Godfrey Smith relates in his book, Other Minds. And he talks about a diver who's goes down to the bottom and just sort of sits very gently with the octopus and, attends it, and gradually reaches out and, makes little motions with his fingers and gets it to explore. And pretty soon the octopus grabs hold of him, by the glove, the dive glove. And octopuses are curious. They'll tug at you, push you away, see if you come back, that kind of stuff. And pretty soon, still holding on to the diver, the octopus gets up out of its den, takes a diver along on a little foraging trip. And, the diver has to kind of buoy himself along with it, but a diver's pretty neutrally buoyant. So the octopus can just kind of hang on to him and takes him on a little circuit and then brings him back to his den. The octopus slips back into his den. He's learning.
Right.
He's learning.
I know we're getting close to the end. So folks, if you have any last minute questions, now's the time to get them in. At the beginning of the book, speaking of learning and speaking as a parent and as a human who likes to learn from books, at the beginning of the book, you talk about yourself being in unfamiliar territory. And you mentioned that you didn't even know how to scuba dive yet. And then you kind of have this 25 years more so of discovery. And so I think I'm kind of curious, what was the first really amazing thing that struck you about octopuses? And now, after all this time working with them, what do you find is your most exciting discovery? What have you learned that really, makes it all worth it?
I think the first really notable thing about octopuses, I work in Alaska. I work on a species called the giant Pacific octopus, or at least I was then. And it's just how big they are. And, I didn't so much discover that as need to know it and find it hard to discover. Because I was planning to take a team of divers underwater. And, this question came up of is that a reasonable course of action? What's my safety management plan if a 100 or 200 or 500 or 600 or 1,000-pound octopus wants to cuddle one of my divers?
Oof.
Right? And so that required me to know, how big do they get? And, that started me down this path of here's a story where the octopus is 600 pounds. Here's a story where the octopus is, quote unquote, several tons. And then here's a story in the Alaska Native culture where the octopus destroys the entire village. And so, there was this continuum of size estimates from big, but not necessarily problematically big, to, take down the Tacoma Narrows Bridge kind of thing. Because, the human imagination.
Big range, yeah.
Making it bigger and bigger and bigger. So that was probably the most engaging first question I could have come up with, because it wasn't something you could answer by just doing an experiment. You needed to read widely. You needed to figure out how world records are set. You needed to consider what's going on. I had one of my colleagues at the science center where I worked had, what was the story? He'd caught he was fishing for halibut, right off the pier there, and or not off the pier, but just offshore. And he in a little boat, and he brought up an octopus, but it was a big one. He figured bigger than 100 pounds. And it when they get to the surface, they want something solid to hold on to. So it grabbed hold of the bottom of the boat, and was kind of half in, half out of the boat, and he eventually had to throw it back because it was just too big to handle in the boat. I mean, I'm sure he would have been happy to bring it home, right. But he couldn't manage it in the boat, and he figured it had to be over 100 pounds, and so it just was unclear, and that made it a great thing to continually pester me to find out more.
Just before we go, I know I'm pushing it here, but I do want to touch on one other important thing that you did bring up again, kind of early on in the book. was that you were noticing population changes over years, that there were fewer and fewer. You mentioned climate change. And Liliana had a question about, like, do octopuses pick up marine toxins from ingestion? So what, how are we affecting them, I guess, is really the big question here. How are our actions, or how are changes in the earth and in the ocean affecting octopus, populations?
Yeah, yeah. To Liliana's question, octopuses aren't filter feeders, and to the best of my knowledge, I've never heard of a case where someone was poisoned by eating octopus flesh. But they do have cephalotoxins, and so their salivary glands can have a toxin in them. If you're bitten by an octopus, that's a very different problem, and that particularly the blue ring octopuses which are very small but distinctly marked individuals, can kill a human. Well, they don't kill you; they just stop you breathing for 20 minutes or so while your liver processes the toxin. So if you can manage 20 or 30 minutes without breathing, you'll be fine. But otherwise, not so much. But I've never heard of a case of marine toxins being concentrated in the flesh of an octopus. They are, as you pointed out, they are intermediate predators. So they're preying on crabs that might themselves have eaten clams or barnacles. They're preying on filter feeders. And so it is possible that toxins would bioaccumulate, but unlike mammals, they don't nurse their young. And so in mammals, we often see toxins bioaccumulating in the eldest, the firstborn of each mother, because the mother dumps her bioaccumulated toxin load into the milk. And that gets, and of course, everything she's accumulated up to her first offspring. And so that nursing can lead to even intergenerational accumulations of biotoxins. I've never heard about that in octopuses. You had another question. In general affecting them. I work up in Alaska. I do think up here, the warming climate has not been helpful to giant Pacific octopuses. My sense is, particularly in the shallowest waters, as the intertidal and the shallow ocean heats up, octopuses are not doing as well. We've seen data from the Puget Sound area as well that says that effect is detectable in samples taken by scuba divers, which would be down to 60 feet or so. That's not going to be universally true. There are areas that might be warming up, and if they were on the cold edge of a warm octopus species distribution, on the edge of the distribution of a warm water octopus that was restricted by that cold, as the water warms up, those octopuses in that region will do better. And there's some documentation of that. Generally speaking, the most difficult thing that we're doing for octopuses, I think, is harvesting. I mean, we're harvesting their predators. We're harvesting their prey. We're just simplifying the productivity of the ocean by removing so much of it. And so really, in my mind, one of the things that we do that perturbs the marine systems the most is simply harvest. We do so much harvest of everything and anything. And even if the harvest is sustainable, that doesn't mean the population is at the level it would have been without the harvest. And so we're still competing or changing the world that all these animals encounter.
Well, thank you so much for your time. We're coming up on the end of our time together. And I just want to give you the floor for any final thoughts or any recommendations you might have for those that want to continue learning about octopuses, and any videos or books you might want to share.
Oh, thank you. Yeah. It might be a little vain of me, but I would hope that my own book, and thank you for reading it, I really appreciate that, is kind of part of what isn't really a planned trilogy, but might be a great trilogy for reading about octopuses. My book focused really heavily on the science, the biology, how these animals, to the best of my knowledge, what are they doing in their behavior, which is so complex and fascinating. But Cy Montgomery's book, The Soul of an Octopus, if you haven't read that already, is a wonderful read, and it really deals with how humans relate to animals that they interact with a lot. How humans, that's really where Cy's work really shines, his human-animal relationships. And so it's very different than mine. And the other volume that is forms a great 3-book series is Peter Gottfried Smith's book, Other Minds. And that really looks at the evolutionary origins of consciousness, how animals are conscious, and what we can expect of that. It's the first book of Peter's to try and address that question. He's got 2 more in the series that continue to more deeply explore consciousness, but octopuses themselves are most deeply explored in his work in Other Minds. And he talks about this site that I described out at Octopolis. For videos, I mean, there is a ton of gorgeously photographed or filmed octopus documentaries out there. Some very whimsical, some very fun. The one I'm going to just selfishly mention is my own. It's released by PBS as Octopus Making Contact, and by BBC as The Octopus in the House, or the Octopus in the Living Room, I think. I can never get that name right. I don't know why. And it was filmed in my own living room, these very walls, and it relates keeping an octopus as a pet with my daughter Laurel, the octopus Heidi. And so if you haven't seen that, that's a great documentary. They're octopuses. It's really hard for there to be a bad octopus documentary.
Right.
You might not get 100% factual truth out of every single octopus documentary, but they all have moments of watching the octopuses. They're just fascinating to watch them move around, and so that always makes them worthwhile.
Well, thank you so much for your time. Thank you for answering our questions. There are even more questions that folks have in there. Everyone, thank you so much for being here today. Let's make sure that you send your thank you in the chats for David and his time today and his amazing book, Many Things Under a Rock. Be sure to read that with us at book club. And then for those young readers that might be tuning in, there is a young readers version that is really great as well. We really thank you for your time, David. This was fascinating. I learned so much from your book, and I've been doing Cephalopod Week with Science Friday for a long time. So, but I deeply appreciated the storytelling elements, the indigenous knowledge that you shared, and then also learning more about these fascinating creatures.
Well, thank you for having me. It's always an honor to be any part of Cephalopod Week. So I really appreciate it. Thank you.
All right. Well, everyone, now head on over to the Science Friday website and click that live button, and you get 2 more wonderful hours of science that you can call in and ask your questions. Thank you, everyone, for today. We will see you again very soon. And in the meantime, share what you're reading with us. Take care. Have a good evening.